This video is brought to you by YTAndrewPaul Tech Repairs. If you have a console, laptop, computer or MacBook in need of repair in the UK or the EU, then have a look in the description below this video for details on how to contact us in order to organise your repair. Right, okay, ladies and gentlemen, and welcome to today's video. And today we're going to be taking a look at this MacBook Air. It's an 820-3435A motherboard, and it has no power. So we're going to have a look at it today and see what's going on. Now, I've plugged it in to see what it does, and actually it doesn't do a lot really, but when you do connect the MagSafe charger, you do get a green light shortly followed by an orange light, which means that the battery is charging. So we are getting some form of power to our MacBook, and basically what's happening is that the MacBook Air has a separate DC in board. So the charger side is handled by a separate board to the actual main board of the machine. So what happens is that the DC in gets generated by the DC in board, it gets passed across to the main board, and the SMC sends a couple of signals back and forth to allow it to charge the battery. So it tells the charger, yep, you can charge the battery, and then sends the current back across the cable down to the main board and into the battery. And of course, in order for that one wire circuit to work, we need a couple of voltage rails. So we need a PP3V42 voltage rail, and we also need PP bus G3 hot. And we know that we have those because we're getting an orange light on our charger. So we know we're getting somewhere, but for whatever reason, we're then not getting the signals and everything else required to power the machine on. So we're either missing a voltage rail or a signal of some kind, and that's what we're going to find out today. So the first thing we're going to do is we know that we have some of the basics present. We know it's not completely dead. So what we're going to do first of all is we're going to take a look and see if we can see anything at all that would give us a visual clue as to why this machine isn't working. And actually the board itself is fairly clean. There's not a lot to it as far as liquid damage or anything goes. So we're just going to go and have a quick look around things, and you can see that it's all relatively tidy. Everything on this portion of the board is absolutely sound, really. There's nothing here that would alert anybody to sort of anything funny going on. It all looks okay. See what I mean? It all looks relatively tidy. There's not an awful lot going on. But then when you flip it over and you take a look, and again, you know, it's not too bad. Yeah, you know, you've got the odd sort of weird deep point. There's obviously some sort of liquid gone on this board because you can kind of see there's a little bit of tarnishing going on sort of around here. You can see that some of the test points are a little bit dirty, a little bit grubby. That's usually water. And then we come over here and we can see there's definitely some shenanigans going on over here, and that's fairly close to the SMC, which is here, the SMC, the system management controller. And we can see we also have some fairly cruddy sort of probe test points around here too. Yeah, that's not looking too clever. So there's definitely something going on here, and it's our job to find out exactly what. Now, obviously, like I say, the best thing to do is to see if you can see anything, you know, a visual indicator as to what's going on, and go from there. And we can certainly see here that whatever is here is not very happy. This is U7600 by my recollection, if I remember rightly. So let's go and take a look and see what U7600 does. At least I'm fairly sure that's U7600 from my memory. So let's go and take a look and see what U7600 does. So we're going to find U7600 on our board view. That's U7600 there. Let's just make sure I have got the right one before we go any further. Yes, I have indeed. Wow, I'm impressed. It's been a while since I've looked at one of these. So as we can see here, U7600 is this little chip here. And we can see we have quite a fair bit of corrosion, certainly on these sort of end 3 pins, the 12, 11, 12 and 13. So what do? So P1V05S0. So these look like 1.5 volt SO rails. So SO is when the power is when the machine is up and running. 12 PP 5 volt S4 and S3 states. So yes, this chip is quite important and manages a couple of voltage rails. So especially for you know, S4, S3, so suspend, hibernate, S0 is when the machine is up and running, and we can see there's all sorts of like enable signals. Power good here, and everything else. So yeah, this is definitely important, and if this isn't working properly, then we could very well end up with what we're seeing, not a lot. So let's have a look and see what U7600 is in the schematic, just to get a bit of a closer idea as to exactly what's going on here. So this is a TPS 51916 QFN. We can see it's marked as critical. It is indeed required, and if we take a look and see exactly what it's doing, this is the 1.05 volt S0 power supply. So yes, without this, we are definitely not going to get anything that we need. So we can see that in the outcome here, across L7630, we ultimately get PP1V05SO. So without this chip, we aren't going to be getting any 1.5 volt rail, and we're not going to get anything out of our MacBook. So this is most definitely an important little IC. 51916 TPS 51916. Okay, now then, so I'm trying to think now if I have any of these. 51916, that rings a bell, you know. That rings a bell. In fact, I'm fairly sure, and this might sound a little bit odd, but I'm fairly sure the Xbox Ones use the same regulator. In fact, when I dig a board out next time, I will just go over and just double check that. But I'm fairly sure they do. So what we're going to do is we're just going to have a bit of a tidy up here and just see what's going on. So the first thing we're going to do is we're going to lift that IC, and to do that, we're just going to pop a little bead of flux around the edge. And I'm going to find my tweezers. Yeah, I'm certain the Xbox One uses the same regulator, which is a bit of a weird one, I know, but so we're just going in here with the quick 861DW air wand. And we're just going to heat this little IC up. My apologies if I just block your view ever so slightly while I'm doing this, but kind of needs must really. Okay, so we have our little chip off there now. So let's just take a look at the pads underneath then. So this is obviously where it's all corroded out from. So we're just going to have a quick clean off with some IPA and a cotton swab. And we're going to see what we've got left to work with here. Okay. Right, so we can see here that there's a probe point just there, and it's black as old sin. But there is something beneath it, which is pretty good. We can see that these other probe points here are all looking rather sorry for themselves. So we'll give these a bit of a run over with some solder and just clean them up a tad before we finished. But yeah, I mean, a lot of people sort of suggest, you know, where do you start with these things? And often the easiest place to start is with your eyes. Just have a look and see what you can see. And it's a lot easier underneath a big microscope like this because obviously, you know, you can see exactly what you need, you know, really close up, and it all looks really nice and big on the display in front of me at the moment. But even with your eyes, you can see there that it's not quite as it should be. And you can see there that orangey red stuff is a bit of corrosion from that pad. That is definitely not great. So I'm just going to go and see if we can get that back a little bit more. And then, of course, you've got the pad that the actual chip itself sits on, which so there's one pad there, which I think is probably just about salvageable. And then you've got the other one here. Doesn't look pretty, does it? Doesn't look very pretty. I'm hoping that hasn't corroded out, because if it has, then it's just going to make life a little bit harder. Oh, there we go. So we're just going to have a scrape away, and you're not really going to hurt anything here. You know, we're just using the tip of our tweezer blade just to loosen things off and just get stuff to a state where we can start to do something with it. So that pad there, those couple of pads there that chip sits on, were definitely not going to be conducive to providing our necessary rails and signals. I can tell you that for nothing. So we're just going to go in with a multimeter now, and we're just going to see if we've managed to restore any of these pads. And it's definitely not happy. We're still getting oil open line. So let's just come back in here. What makes me think we're going to be running crappy little jumper wires? We're going to be running crappy little jumper wires, I think, here. But we shall see. So we'll just give it another clean up. What we'll do as well while we're here, pop a dab of flux on there, and we'll just get some solder onto that pad. And the test point, just to tidy things up. Okay. So the flux we're using here, by the way, is Amtech NC559 V2TF. Very, very highly recommended flux. Just give that another quick brush. Honestly, leaving Q-tip behind is never a good thing to do. Never a good thing if you're trying to be tidy. Never a good thing if you're trying to be tidy. Okay, so that should now read from here. We still get OL, open line, which is never good. So what pin is that? That is pin 12, ladies and gentlemen. So yeah, indeed, it does go to that cap and that test point, and we're still getting bugger all. So I think it's possibly corroded the trace out. So that's not cool. That's certainly not great. Yeah, that IC is toast as well. If we have a look underneath here, that's definitely had it. Right, okay, so I knew I had some somewhere and I have managed to locate one. So that's what we're going to have a look at next. But what we're going to do first of all, before we do anything else, we're just going to tidy this area of the board up. I'm just going to run some solder, a little bit of flux and everything over here. I just want to tidy those test points up a little bit because although they're test points, don't underestimate them because they do sit on the trace. So because they're on the trace, if the test point is corroded out, then quite often the trace that it links to will also be gone. So it's not quite as easy as going, oh, it's only a test point, doesn't matter, because quite often it does. So there's one just to be careful not to fall foul of there. If you're doing this sort of work and you find something on your own board that you suspect isn't quite right. So we're just going through here and just tinning these test points up because of course they are gone. So we do need to make sure that they don't do too much damage to us. So yeah, we're not getting any continuity at all to here. We do here, but then it breaks. So there must be some sort of break in the trace underneath there. So we're probably going to end up running a bloody link wire, which will be fun. Yes, so next thing I'm going to do is I'm going to get hold of my donor IC. In typical fashion, I seem to have misplaced it. Okay, so this is our new IC. Hold it roughly in position just to get it started. Okay, so that's just going to get it started there now. So we'll just come back in with the end. Probably I'm just going to lift you slightly further away from the board so I've got a little bit more room to work with. It's better. So my apologies if I do block you here for a sec, but so it may look like a lot of flux, but what will happen is that as the solder pads beneath the chip become molten, and that big ground pad in the centre does, surface tension will pull the little IC back straight in the middle of the pads, and that's just what's happening now. It's lining up nicely. You give it a bit of a wiggle back and forth, and there we go. We're back in place. Okie dokie. So that's our chip back on where we want it to be. So I'm just going to give this a bit of a clean with some IPA, just to remove some of the residue. Some of these pads here. Problem, of course, when you hit the board with some hot IPA, occasionally it can tarnishes your connections. It's easily resolved, you know, you just give it a clean off. We'll do that before we've finished, but it's kind of makes seem where you're going and what you're doing a little bit harder. Okay, so there we go. Okay, so we know that we're not getting anything on that test point at the moment, so we're just going to go and double check that now. So of course it comes from this pin of the IC to this side of the capacitor, and we are getting OL open line. And again from that portion of the trace to the test point as well. We're getting nothing. So what we're going to have to do now, we're going to have to run a tiny little link wire from that pin of the IC across to that side of, well, we're going to link it to the test point, to be honest. But this can be fiddly work. So we're just going to strip back some enamelled wire. So this is really fine enamelled wire. Where is it? There it is. Okie doke. So we're just going, again, tiny bit of flux. Okie doke. So, just going to do the same again. I probably should trim a little bit of this wire off, to be fair, but okay, so we're just going to fold that over. Onto that there test point. A little bit better. Alright, so what we're going to do now is we're just going to give this another clean off. Get some isopropyl. Okay, and I seem to have got tangled up in my link wire, which is annoying. Go away. Okay, so we have our link wire there now. You can just about see. We hold it up. That seat's in position on that pad. There we go. Okay, so we should now be able to see that we get continuity from that pad. So if we go directly from the pin to the side of the resistor now, we should get, we do, 1 ohm and dropping. Lovely jubbly. This test point here I do believe is for the end one. We get, yeah, 1.5 ohms and dropping. There's no continuity there. No, and there's no continuity to the one next door. No, fantastic. Right, lovely. So that's all well and good there. So what we'll do is we'll just see if that's enough to get this thing back and working again. Right, okay then guys, so apologies for the rush testing, but this last couple of days has been a nightmare. So unfortunately we didn't get a chance to test it the other night in the office, because when we put it back together there was no, well, there was an SSD in the machine, but it had no operating system on there. So I had to bring it away to put macOS back on there. Of course we've updated it to the latest Mojave version. So of course we're running off battery now because I'm just in the car. I'm just going to box all these back up and get them away, you know, back to where they need to go. But beforehand I just want to show you, we press the power button, get a nice long dong there, an Apple logo, and that will now boot into the OS, and everything will be absolutely fine and dandy. Just wait for it to come up. There we go. It does boot really, really quickly, does this new Mojave version of OS X. I'm really quite impressed. But yes, so there you go, ladies and gentlemen. MacBook Air, all back together, present correct, and of course our PP1V05 S4RS3 line all back up and running again now. And as you can see now, our machine is firing up, lovely, and working once again. So thank you for watching. Hopefully you've enjoyed it and you found it useful. If you have, please remember to go and stick a big thumbs up down on the underneath the video there. It helps me and it helps the channel grow. Likewise, if you've any comments or any questions at all, then feel free to pop them in the comments below. If you would like a repair of your own and you're in the UK or the EU, then drop me an email to my business email address. It's YTAndrewPaul@outlook.com. That is in the description of the video below, just in case you didn't catch it. Likewise, if you want to send me a question in private on Twitter or something like that, you can do. My DM box is open to everybody there. My Twitter handle is @YTAndrewPaul. And again, you know, I try to pick everything up in there too. If you are going to send me a message on Twitter, you'd be better off inboxing me than tweeting at me. I don't often check tweets at me, so I can miss things. But if you drop me a DM, then I should pick it up over the next couple of days or so. Yes, so thank you very much for watching. Like I say, hopefully you found it useful. If you have, then I think this is the 100th video we've uploaded to YouTube. So it's quite a landmark there. So yes, if you haven't already, if you want to pop a subscription and hit that bell icon, that will alert you to any future uploads that we put on the channel. If this is the first video you've seen on the channel, then feel free to take a look through our other stuff. We've got more MacBook repair stuff. We've got some iPhone stuff. Not that I really do iPhone, but where needs must for family and friends has been. There is some on there. Most of it is sort of games console related, so PS4, Xbox One, that sort of stuff. And one or two other little odds and sods as well. But yes, so I'm sure if you like this sort of content, then there'll be something on there for you to while away some hours when you're bored. So thank you very much for watching. I've been Andy Paul. This MacBook is now working again. You've been fantastic as always, and I will see you on the next video in the not too distant future. So from me, for now, is bye-bye, and I'll see you shortly. Many thanks for watching then, ladies and gentlemen. Hopefully you've enjoyed this video. If you have, then why not check out these recommendations below. Also, please remember to comment, rate, and of course subscribe to the channel if you found this useful. We've plenty more content on there, and there's lots more to come.